Hey, this is going to be a video for notes on lesson 7. We're continuing on with the square root method of solving for quadratics. I am going to upload a copy of this, so you could probably access that and just follow along with me, or if you're thinking it's good for you to take these on your own. For now, I am not going to have you upload notes. If it starts to look like people are seeking help and they don't have notes to refer to, I might need to do that at that time, okay? But for now, we're just going to hope that you use them in a beneficial way, okay? So the square root method last week was when we had standard form equations where there was no b value, right? So it was ax plus 0x plus c, and so 0 times x, 0, it's just not there, right? And we could do square root method then because we could just isolate x squared. We could add or subtract c using inverse operations, divide by a, and then our last step would be to square root both sides, right? Well, the other way we can do that is when we have an equation in vertex form, like we saw with that pre-thinking video. So vertex form, remember, is right here, right? So let's I'm going to do about 3 different examples on here. I've got this one started for us. The first thing we should recognize is that we've got 2 variables in this, which is unusual for us. We haven't really had a lot of x and y, just expressions so far. So the first thing we want to do is set this up so that y equals 0. So solutions are when y equals 0. It's those x-intercepts or roots that you keep hearing me talk about. So I'm just going to rewrite this with y equals 0. Okay, and now I'm just going to jump into doing inverse operations. So the only thing that's happening to this square portion that I want to isolate is that we're subtracting 25. So I'm just going to add 25 to both sides. So why did I do all that? Because now what's isolated or alone is the square. The square isn't just a variable now. The square is this binomial. And you know, you could maybe visualize that over here, right? We know what's inside is 25, right? Don't know how it's broken up though, right? Anyway, now our last step, if we're doing inverse operations, is to find the square root of both sides. And so we're square rooting to get rid of this exponent, and what remains is just the binomial. And what is it going to equal? 5. What else? Not just 5. Positive or negative 5, right? So we're probably going to see 2 solutions, meaning this quadratic is going to cross the x-axis twice, right? Now, what am I going to do now, though? Well, if you think of these parentheses as not being there anymore, we've got a couple options. X plus 2 could equal positive 5. X plus 2 could also equal negative 5. So I'm just going to solve it both ways, right? You know, the process on both of these is going to be the same. Subtract 2 to get x alone, right? And we get x equals 3. Here we're going to get x equals negative 7. So what does that tell us? So we have 2 x-intercepts. When y equals 0, x is 3, and it's also negative 7. So I've just written the intercepts. If we were asked to write the solutions, we could do a set notation. Here we got x, y, x, y. Set notation is just to take those numbers, the negative 7 as an x-intercept and 3 as an x-intercept, and write them as a set. Okay, so these are just the roots, root 1, root 2. Where is it crossing the x-axis, right? So roots or zeros. Roots, zeros, intercepts, all kind of refer to the same thing, x-intercepts, I should say. Okay? Okay. Next kind of problem you're probably going to encounter will have a little more going on, like 5 of these squares. We're going to have it set to equal 40. So y isn't there, is it? Okay, so don't have to worry about setting y to be 0. I'm going to try to isolate the square by dividing by 5. So I have to undo multiplication before I undo exponent. I'm going to divide both sides by 5. Keep it balanced. So now x plus 1, that binomial is over here. My solving step to undo squaring, square rooting, do it to one side, do it to the other. So now x plus 1, that binomial is alone. It's going to equal positive, sorry, it's just going to equal positive or negative square root of 8. Square root of 8, we don't know what that is. We can approximate it, right? What if I simplified it, though? Do you remember how we reviewed that last week? Pulled out the perfect square of 4 to get 2 roots of 2, right? So this, again, positive or negative. Haven't solved for x yet, though. I still have to do that. Take 1 away from both sides. Right? Oh, sorry, wait. Jumping a little ahead of myself. X plus 1 equals, let's say, positive 2 roots of 2. X plus 1 equals negative 2 roots of 2. Now I can start solving. Add 1 to both sides. I don't know why I'm saying add 1. Subtract 1 from both sides. See how much candy I'd be handing out if we were actually in class? Bet you missed that, huh? Every time you catch one of my computer mistakes. All right, so we're going to subtract 1 from both sides, so x is going to be 2 roots of 2 minus 1. Or x is going to be negative 2 roots of 2 minus 1. Now this is a little quirky because these, this part is the same. I could write this, stay with me, as negative 1 and a positive or negative 2 roots of 2 as my solution set. So we're crossing the x-axis at these 2 points, negative 1, positive 2 roots of 2, negative 1, minus 2 roots of 2. Okay, last one. This one is going to have a few more steps going on. 2 squares of x plus 4 minus 5 equals 45. Sorry, cutting that a little close, aren't I? Right, inverse operations again. When I see it's in vertex form, I can isolate the square using square root method. So if I reverse PEMDAS, the first thing I'm going to undo is subtraction. We're going to add 5 to both sides. And what's left are still those 2 squares of x plus 4. Now we're at 50. Undo multiplication before exponents. Divide by 2. Divide by 2. And we'll have x plus 4 squared. That square is alone now, so I can undo that by finding its square root, right? And x plus 4 is alone now, being either 5 positive or negative, right? Square root of 25, positive or negative 5. Now, 2 ways. X plus 4 could equal plain old 5. X plus 4 could equal negative 5. Will equal these ones because it probably crosses that axis twice, right? All right, so if I subtract 4 from both sides, x is going to equal 1. If I subtract 4 from both sides here, x is going to equal negative 9. Again, a couple things that tells me solutions are 1 and negative 9. I like to do them in order because I kind of want to visualize this on the graph. Where is it crossing the x-axis? These are the roots. They're also called the x-intercepts, right? So I could write them as ordered pairs. It's when y is 0. Where is it cross? You'll notice that our equation wasn't set for y equals 0. There's still other points on that graph that are technically solutions, right? But we tend to focus on when y is 0 because it has a lot of meaning and context, which hopefully we're going to get to in the weeks to come, okay? Again, you can, I think, like I said, I'm going to upload this so you can print these off and keep them and use them for your practice on this method. We're going to kind of continue on with a new twist of this tomorrow, okay?